So hello everyone, I welcome you in my class. So in the last class we have discussed the roll loop, and we have also given the hint that after a roll loop there will be the heading loop that will try to control the heading or quotes, whatever you can say. Okay, if there is a no wind, that means heading angle will become the course angle. Okay, and you know that heading angle means what the body x-axis is making with the north. When you are flying in a north direction, that means heading angle is 0. We will cover the following, like in a we have talked about the gain scheduling in a longitudinal case, where we have seen that first you design the controller on a one center trim point, and remaining other trim point you can schedule the gain based on the dynamic pressure, okay, or speed square. We have also discussed that if the plant is very stable, then only one gain is required, or in a single gain the things will work. And if the plant is becoming more non-linear, then very tight scheduling is required. That means dynamic pressure based gain scheduling you have to perform. Okay, so same gain scheduling things we have done in this case also. And in a lateral autopilot design and analysis, in today we will try to analyze the control loop, roll control loop. We will try to analyze in more detail. So that means these two control, roll hold and heading hold, we will try to analyze, and most inner loop also we will see, that means rate loop. Okay, just I want to tell you one thing. When you try to, the only purpose is I want to attain some particular heading angle. Okay, let's say aircraft is flying in a north direction. I want to take a turn and I want to fly, let's say 45 degree or 90 degree, like that. Okay, so what you will do here, first you will deflect the aileron. Okay, depending upon the right roll or left roll, you have to deflect the aileron. For example, a right roll, you have to deflect the aileron this down, this up. So you should make this L plus delta L lift here and L minus delta L, so that it will roll. That means when you deflect the aileron, there will be the change in roll rate. Okay, this roll rate will try to achieve some bank angle. As aircraft bank, there will be centripetal force that will try to rotate the aircraft in a circular path, and once you have achieved the heading angle, you can bring back to the bank angle to the 0. Okay, and you can start flying continuously. Okay, so that is the purpose of this lecture. So as we have done in the longitudinal case, we have to make sure that the gain into dynamic pressure will be the constant, because in longitudinal case we have seen that dynamic pressure based gain scheduling. Okay, so if you want to know how I have plotted this, then you can go back to my aircraft longitudinal autopilot design lectures. So you can see that as we did in the longitudinal case, same things we have repeated here for a roll loop case. That means all the 7 trim point we have plotted the gain margin, phase crossover frequency, gain crossover frequency, with the brake at feedback, and with the brake at actuator. Brake at actuator, that means you are dealing with the most inner loop, and you are dealing with delta E into P type loop, and when you are taking the feedback of a phi, you break the feedback and you can plot the gain margin, phase margin. Okay, so you remember that gain margin and phase margin, these are things for a open loop case. It is very important. People generally confuse between what do you mean by the brake at feedback and brake at actuator. Okay, so that means forget about all the loop, you consider this to this only. It is called brake at actuator. Okay, you take a you make a cut here. Okay, you close this loop and make a cut here. That means without any feedback of phi, if you are dealing, that means you have given some phi, you are getting phi without any feedback, that means brake at feedback. So that is how I have written brake at feedback and brake at actuator. So this is without delay and this is with delay, and 80 millisecond we have considered the delay. Okay, using Pardee approximation, and the altitude is 0, 8,000 feet, 16,000 feet, and this is the weak calibrated airspeed. See, when you go for a higher and higher altitude, okay, so that means what? true airspeed will change, right? But equivalent airspeed will remain same, right? And since when you measure the speed using pitot tube, there will be error, right? So you have to calibrate, right? So after the calibration, what speed you are getting, that is calibrated airspeed. Okay, because every component has to be calibrated, right? Okay, so now if I want to check my how my heating loop is behaving, okay, then you have to give a for example, I have given a 10-degree psi command. That means let's say I am flying in a north direction. I just commanded 10-degree psi. So physically, what will happen? Aircraft will roll, right? And then using centripetal force, it will try to take a turn. And once 10-degree achieves, bring back to the normal. Okay. Now, so that means heating angle is achieved, right? But along with the heating angle, we have to see the other parameter also, because there is a aircraft is a 60 degree of freedom, so you have to monitor all other parameters in order to make sure we are within the envelope. So heating angle is achieved and all the parameters are within the acceptable limit, and you can see not only aileron is required but rudder is also required. Why? Because when I will talk with when I will give the lecture on aircraft directional control design and analysis, then I will tell you what is the importance of rudder. But here some kind of feel you can have it. Let's say you have a make a turn in order to achieve the desired heating angle. What happens? Let's say if it is turning, this is more lift here, less lift here, so more drag here, less drag here, it will take a yeah in this direction. So you have to prevent this here, right? You have to always take a turn in such a manner that your side slip angle should be 0. You should not skid and you should not slip. Okay, skidding means, let's say the radius of turn is skidding means you are going away. Okay, and side slipping means you are moving forward also, you are moving lateral also. That means you are not actually taking a turn towards the center of the turn. Okay, side slip angle I already explained to you what the relative airspeed making with the plane of symmetry, that is nothing but the beta. So every time you have to make a turn in a such manner, you have to be in a perfect circle. Okay, and since when you deflect, there is a lift component L cos phi, L sin phi. L sin phi will be responsible for making a turn physics wise. Okay, and L cos phi is in order to balance the weight, and L cos phi is less than what is W. That means if you are flying at a steady state level flight, that means the lift is L, and let's say this is L dash in a steady state level flight. So L cos phi will be less than L dash, right? So in order to make it same, what we will do? You will try to increase the L so that L cos phi balanced by the weight. So how you can increase? Either by increasing the speed or putting the elevator up in order to increase the angle of attack. When the angle of attack increases, CL increases, lift increases. Okay, so this is why you can see that in reality there will be elevator is also required, and there is some kind of trim drag also. So drag will also increase. So you have to put the additional thrust setting in order to make a thrust equal to drag. Okay, so that means all the 4 primary controls are required in order to make a perfect turn. So when I say coordinated turn, that means aircraft is taking turn with a side slip angle 0 and it is not losing its altitude as well. That is called coordinated turn. Okay, so when I will teach you the aircraft direction autopilot, then you will see that how beautifully rudder plays the important role in order to make the flight coordinated. So as of now we have done the 10 degree, then let's do for a 360 sweep, complete sweep. Okay, so let's say I have commanded 360-degree sweep with a standard turn of a 3 degree per second. See, you can have some slope, right? So that slope is 3 degree per second. In a Boeing aircraft and Airbus aircraft, Airbus A380, A320, Boeing 747, all has some standard turn rate. You cannot go beyond that. 3 degree per second. That means 3 degree in a 1 second heating you can maintain. Okay, so that is how the same command I have given, and it's perfectly achieving in all considered trim point, 7 point. Okay, you can see that how my aileron deflection is there, and in order to make the coordinated turn rudder is required, and in order to make a attain that the hitching angle, how much bank is required, and finally the bank is going to 0, right? Once you achieve the required hitting angle, it will bring back to the 0. Okay, that is how in all the cases it is going to the 0 finally, right? Okay, and you have to make sure that the control surface rate is also within the limit. That means when you are deflecting this aileron, so there is a limitation on rate. So to make sure that delta A dot, delta R dot are within the acceptable limit. Okay, and see finally also beta is going to 0, right? Okay, so that is how you achieve the perfect turn. Okay, but the major control is what? What is the main control is required in order to make the turn? Aileron, right? See, dominant motion you can achieve using this, but in order to make it perfect, you have to use the other controls also. So we have seen that in perfect turn, coordinated turn, all the 4 controls are required. And this is how using block diagram you can understand. First, in the last class we have modeled P by del A, right? Transfer function. Okay. What you will do? Take actuator dynamics, put the position first and then rate limit. Okay. Introduce filter. Okay. And if you tune the gain to get the desired damping. Okay. Because when you say desired damping, I mean to say when you do the open loop analysis, you have a damping 0.2, 0.3, but this is not sufficient. You have to go, let's say 0.7, then you have to plot the root locus of this and select this gain, okay, in order to get the desired damping. Okay, because we have seen that there is a 3 mode: spiral mode, roll mode, and Dutch roll mode. So we have to make sure that all modes are satisfactory, giving the are not providing any kind of problem in a flight. Okay, perfect. When I will teach you the aircraft directional control, I mean to say aircraft directional autopilot design analysis, then I will tell you the significance of the filter. I will tell you the washout filter, and I will tell you the significance of filter, because you have to remove the unwanted signal. If you include that signal, that will try to disturb. Okay, so I will tell you the physics of this filter. Okay, once you deflect aileron, roll rate will be generated, integrate, you will get the phi. Okay, you close the loop and you tune the using PI controller in order to get the desired roll angle. That up to that we have discussed, right? Okay, when you roll, there will be the change in the heading due to centripetal force, right? So by physics point of view, you can make a one more outer loop and you can consider as a heading loop. Okay, you take a feedback of this, and if you want to command something, let's say 45 degree, 55 degree, and similarly using this again put the PI controller, and you can have a side degree desired. And since G Vg by S, you can simply physics wise you can write here. You write the turn equation side article 2, and you can make it how we are getting the psi. Okay, and one more thing, one more important part. I have written Vg here. That means ground speed. If you include the ground speed, that means you have to deal with the course angle. And for example, let's say when it coming from the crosswind, is cross direction, so you have to consider the ground speed. Why ground speed? Because ground speed decides where you are going, and it is a navigating element, psi. So you have to deal with the ground speed, not the relative air speed. Okay. So I am repeating, when the wind is there, course angle and heading angle is different, and when there is no wind, course angle and heading angle are same, right? One more thing, when I say wind, that means I am dealing with the generalized condition, crosswind only. Okay, any angle. Okay, so this is all about the lateral autopilot design analysis. So this part is completed. So in the next class, what I will do, I will move towards the aircraft directional autopilot design and control, where you can see the significance of the rudder. So we have understood that how can you design the autopilot with the actuator, elevator, throttle. Elevator, throttle plays the role in designing the longitudinal autopilot, and aileron is for a roll hold, course hold. Okay, and finally last, which is most important control surface, rudder, we will try to design in a next class, like how will you deflect the rudder in an automated manner in order to achieve the perfect coordinated flight and in order to handle the wind and all. So that we will discuss in the next class. Thank you so much.